everyone, this is Janine the Tutor, your favorite math and science coach. Let's get better grades in life, shall we? In this video, I will be covering naming ionic compounds and molecular compounds because several students seem to struggle on this concept. So without further ado, let's begin. First of all, let's just ask ourselves, what's the difference between an ionic compound and a molecular compound? So an ionic compound consists of a metal and a non-metal, while a molecular compound consists of two non-metals. So if we're looking at ionic compounds, we have three different types. We have binary, multivalent, and polyatomic. So for binary, which means two elements, for instance, we're looking at sodium chloride. Sodium is found in group 1 of the periodic table, therefore it must carry a charge of +1. Chlorine is found in group 7, therefore it carries a charge of -1. When you cross over or switch the oxidation numbers of sodium and chlorine, you end up with NaCl for sodium chloride. Moving on to calcium nitride, calcium is found in group 2 of the periodic table, therefore it must carry a charge of +2. Nitrogen is found in group 5, therefore it must carry a charge of -3. Crossing over results to Ca3N2 for calcium nitride. Moving on to magnesium oxide, magnesium is found in group 2, therefore it carries a charge of +2. Oxygen is found in group 6, therefore it carries a charge of -2. When you cross over the oxidation numbers of magnesium and oxygen, you should end up with Mg2O2. However, you can cancel the 2 out such that you're left with MgO for magnesium oxide. Now moving on to multivalent, this is very similar to binary such that the non-metal component takes the suffix IDE just like binary. However, there's two ways to name this such that you have stock and classical because your metal is multivalent, meaning it can take more than one charge. So you look at the charge, and if you're using Roman numerals, then this is your stock way of naming your multivalent ionic compound. However, if you're looking at the charge, but depending on whether the charge is lower, then you would use us for the classical way of naming, and if it's a higher charge, then you would use ik. So if we're looking at FeCl2, we know that crossing over results to iron having a charge of +2 instead of +3, therefore iron is taking the lower charge such that it's now iron 2 chloride or ferrous chloride. Moving on to copper bromide, we know that copper must be +1 instead of +2 as a result of copper and bromine crossing over their oxidation numbers. Therefore, copper is taking the lower charge since copper has the possibility of having +1 or +2 as its charge. But since copper is +1, therefore it's copper 1 bromide or cuprous bromide. Moving on to polyatomic, the only difference here is the non-metal component does not change in spelling. So if we're looking at calcium carbonate, we know that calcium is in group 2, therefore it has a charge of +2. Carbonate is -2, crossing over results to Ca2CO32. However, you can cancel the 2 out such that you have CaCO3. Moving on to aluminum sulfate, we have Al2SO43. As a result of crossing over, we know that aluminum must have a charge of +3. Sulfate must have a charge of -2. Therefore, we have Al2SO43 for aluminum sulfate. So regardless of whether we're looking at binary, multivalent, or polyatomic, it's important to keep in mind that for ionic compounds, you need to cross over or switch your oxidation numbers no matter what. Now moving on to molecular compounds, as I mentioned, you have two nonmetals for molecular compounds. However, in this case, we use prefixes to indicate the number of atoms instead of crossing over your oxidation number. So again, I repeat, molecular compounds, you don't cross over your oxidation numbers here. Instead, you use prefixes. The only exception here is if your first atom is a single atom, for example, you have nitrogen trichloride, you don't say mono nitrogen. Instead, you just drop the mono and you say nitrogen trichloride. And remember to keep in mind that if you have tetra, penta, hexa, hepta, and octa, you need to drop your A if it's preceded by a vowel. For example, you're looking at diphosphorus pentoxide and not pentaoxide. Now let's proceed to practice. So for the first question, we have BAI2. We know that barium is a metal because it's found in group 2. Therefore, it carries a charge of +2 as a result of crossing over your oxidation numbers. Iodine has a charge of -1. Therefore, we know that this is an ionic compound, so we need to have a metal and non-metal such that the suffix of our non-metal would be IDE. So we say that the name of BAI2 is barium iodide. Moving on to NCl3, we know that this is a molecular compound, therefore we say that it's nitrogen trichloride because we drop the mono if our first atom is a single atom. Moving on to P4O10, we know that this is also a molecular compound. Therefore, there's 4 atoms of phosphorus, so it's tetra phosphorus, and it's decoxide because it's 10. So instead of being deca, you drop the A, therefore it's decoxide. Now moving on to COBr3, we know that this is an ionic compound such that cobalt is +3 and bromine is -1 as a result of crossing over your oxidation numbers. Therefore, we say that this is cobalt 3 bromide, keeping the suffix IDE since it's an ionic compound and it's multivalent. Alternatively, we can also say that this is cobaltic bromide. Moving on to Mn3PO4, since this is an ionic compound, therefore we need to cross over their oxidation numbers. So we know that manganese has a charge of +4, while phosphate has a charge of -3. Therefore, this is manganese. For phosphate. Or we can say that this is manganic phosphate. And there you have it. I hope you found this video insightful. If you do, please don't forget to subscribe to the channel, hit the notification bell, and give me a thumbs up. Once again, this is Janine the Tutor, helping you reach your learning goals faster. And I'll see you on my next class. Bye guys!